going to be looking at some lab analysis problems. So we're going to be looking at gravimetric analysis and titrations. And typically what they'll do is they will ask you to solve for a percentage. Not always, but sometimes they usually involve finding a percent of something in a mixture. So gravimetric analysis is basically the way to determine a quantity of something that you're interested in, so an analyte, based on the mass of a solid. So typically what you'll do is you'll have some sort of chemical reaction where you have a precipitate and then you go and you weigh that precipitate afterwards and then use the amount of the precipitate to go back to one of the reactants. Alright, so here's a typical example. So I have a 3-gram sample of an alloy which contains lead and tin. And it was dissolved in nitric acid. Sulfuric acid was then added to the solution, which precipitated 1.69 grams of lead sulfate. Assuming that all the lead was precipitated, what is the percentage of 10 in the sample? So first thing, it's looking for a percent of 10. So we're going to focus with the main question. So if I want a percentage of 10 in this alloy, I need two numbers. I need the mass of the 10 by itself, and then I also need the mass of the alloy. So the mass of the alloy is 3, and I don't have the mass of the 10 by itself. But what I do have is the amount of lead sulfate. So typically when you're given any kind of gravimetric analysis, first thing you should do is say, okay, what are they asking for? What two numbers do I need? Or what numbers do I need to get out of this data? Then go back and look. If they collected a precipitate, that's usually what you're going to start with. So here, they don't have the reaction written here, but I know that I'm interested in this lead sulfate that we collected. Well, what makes this lead sulfate? Well, lead ions and also sulfate ions. Well, inside of our alloy, we have 10 and then we also have lead. So if I can figure out how much lead was in the alloy, then I can easily figure out the amount of 10 that was in the alloy and get my percentage. And I was given the amount of lead sulfate. Well, if I was given the amount of lead sulfate, can I figure out how much lead led to the 1.69 grams? So I'm going to start with my precipitate. So I have 1.69 grams of lead sulfate. Let's figure out how many grams of lead it took to make that lead sulfate. So let's go to moles. So remember, if we're going from one substance to a different substance, you have to use a chemical reaction for this. And the reaction that we have here, if we make the lead sulfate comes from the lead ions and the sulfate ions. The sulfate came from the sulfuric acid. So 1 mole of lead sulfate weighs about 300 grams. Okay, so now I'm in moles of what I have. Now I can go to moles of what I want, which is the lead, which happens to be a 1-to-1 ratio. And then I can figure out how many grams made this. So that's 207.2, and that's going to give me 1.154 grams of lead. All right, so the thing is, it's asking for the percentage of 10, so there's a couple different ways to actually get that percentage, but I know that the whole alloy weighs 3 grams, and I know that the lead by itself was this. So now I'm going to just subtract and take the difference, and then that will give me 1.846, and then this should just be 10. Well, now can I find the percentage of 10? Well, I needed the mass of 10, which I now have. I needed the mass of the alloy, so now I can just plug it in. Times 100, and that's going to give me 61%. All right, so volumetric analysis is going to be a titration. So this is where you slowly add one solution, where you typically know the concentration, and you add it to a known volume of another solution where you don't know the concentration. You're interested in the thing that you're titrating typically. The titrant is going to be added. So the titrant is what you put into the burette, and it's going to be added until the analyte has been completely consumed. So completely reacted out. Usually what you'll be looking at is an indicator. So if we have an acid-base reaction, we can use an indicator which changes color with the pH change. You can also use pH meter to know when to stop. And there are other types of titrations besides just acid and bases. But typically there's some sort of indicator which will change colors to indicate that whatever you're looking at, the thing that you're interested in, has been completely reacted. Okay, so typically what you're going to have a burette. And you're going to have something that you're interested in. Okay, and what you'll do is, if you know the molarity of the thing that's in your burette, you will continue to add that thing until all of this has reacted. Then you'll have the volume of how much you added of whatever was in the burette. You have the molarity, and then you also know how much of the analyte you started with, the volume rather. You don't know how many moles are in that, but you can use the chemical reaction to figure out how many moles did you react in this titration. All right, so when we look at a titration, your titrant is going to be added to the titrate. Okay, so the titrate is whatever you're titrating, which is typically the thing that we're interested in, until the endpoint has been met. So that's typically going to be an indicator changing colors. The equivalence point is when the amount of the moles of the titrant is added is equal to the analyte. Okay, so when the moles of one is equal to the other, or we can say that the moles of whatever you're interested in has been consumed at that point. Acid-base reactions is going to be a 1-to-1 ratio, so the equivalent, they'll be equal to each other. All right, so let's look at a typical titration problem. So I have 25 milliliters of a solution of sodium hydroxide of an unknown concentration, required 23.65 milliliters of 0.1 moles per liter of hydrochloric acid for complete neutralization. Calculate the concentration of the sodium hydroxide. Well, we have sodium hydroxide, we have HCl, we're going to react it out and get sodium chloride and water. And that everything's a 1-to-1 ratio. So what do we know? We know that we had 25 milliliters of this. I don't know the molarity of this. I also know that it required 23.65 milliliters of the HCl. And I know the molarity of that. So if I want the concentration of the sodium hydroxide, so the molarity, I need two numbers. I need the moles of the sodium hydroxide, and I also need the volume. Well, I have the volume, that's 25 milliliters. I do not have the moles, but I do know how many moles, or I can figure out how many moles of HCl reacted with that. So I'm going to use my HCl to figure out how many moles of sodium hydroxide reacted. So typically in a titration problem, you're going to start with the thing that you know the most information about, which is HCl. And we don't start with molarity because the molarity is a conversion factor between moles and liters. So 23.65 milliliters, or 0.02365 liters. Let's figure out how many moles of HCl that is. So it's going to be 0.1 moles is equal to 1 liter, because we use this, our molarity, as our conversion factor. All right, so now we're going to figure out how many moles of sodium hydroxide, that is. So now we have moles of what we have. Now we go to moles of what we want. It's a 1-to-1 ratio. And once I do that, I get 0.0200236. Well, now I want the concentration, so I just divide it by the volume of 25 milliliters, which is 0.025 liters. So that gives me a molarity of 0.0946, big M. This is the most typical type of titration problem that you could be given. So when you have a titration problem, write out the reaction first, okay? Then what you do is you look, okay, what do I have the most information about? That's typically going to be your starting point. And then if you're looking for molarity, well, what numbers do you need? You need the moles of that substance and you need the volume. What do you have? What do you need?